All right. Good noon. Well, it's a little bit afternoon. Hello. My name is Chuck Heinzelman. I am a principal PM manager on the Azure data team responsible for in-database engine analytics.
And my name is Ajay Jagannathan. I lead the SQL Server and Arc SQL team.
Sorry, just didn't feel like I was on. All right, and we are here to talk to you about analytics in SQL Server and Azure SQL. So we have analytics platforms. We have dedicated analytics platforms like Synapse Analytics and Power BI, but we also have analytics capabilities in the SQL Server and SQL Database engine. So the things we want to talk to you about today are HTAP and Translytical workloads. Translytical, I know there are people that hate it when I use the term translytical because it's a made-up word, but it's a word that kind of fits what we're trying to do. The transactional and analytical hybrid. We're going to talk a little bit about that. We also have a section on data virtualization. How do we get additional data that's not in our engine incorporated into these analytical workloads and into the engine workloads? And then we're going to talk a little bit about Azure Synapse Link for SQL. We'll do that at the end. And since these are three distinct sections, we'll probably pause at the end of each section for question and answer. Sound like a good way to spend the next 50 minutes or so?
Yep.
All right, let's do it. So the first thing I want to talk about is the HTAP and Translytical workloads. What are these? What does this really mean? Well, if you think about it, so Gartner coined the term HTAP, Forrester coined the term translytical. Originally, the HTAP definition was really tied to in-memory. That's why I like the translytical term better, because translytics really is that melding of transactional and analytical. How can we do both of these workloads effectively with a single engine with zero or minimal data duplication, or even just the necessary data duplication? So what kind of features do we have in the engine to do this kind of thing? Well, one is we have the in-memory OLTP. You think a lot about that for performance, but it also drives a lot of translytical workloads. We'll see that in the demo that I'm going to do. Column store indexes, of course. You can't do this kind of workload effectively without good column store index, and we have both clustered and non-clustered column store. Multi-model. How many people think of this when they think about translytical workloads or analytical combined with transactional? How do we deal with JSON, so document data? How do we deal with key value pairs? How do we deal with all these different geometry, geography, all of those in the same engine, without having to add additional tools, without having to learn a whole new way of doing things? We're going to talk a little bit about that too. Intelligent query processing. Our query processor is always getting better. I remember back in the day when we used to crow about we added star schema enhancements to the query optimizer. We're constantly working on the query processor to make things better for all things, but analytics is definitely one of the things we do add in there. ML services. Being able to score an ML model right from within your database engine. And then one of the easiest things to help you with your translytical workloads is the ability to use readable secondaries. Think about it. You want to offload that workload from your primary. If you got an active OLTP system, your primary is very busy already. Let's take some of those analytical workloads and offload them. All right, we're going to jump into a demo here, and hopefully, the demo overlords are working well for me here.
Duplicate.
And of course, I think I have to end the slideshow, so let me end that. Oh yeah, that's the classic problem with this. Let me just switch over to the right window. There we are. Okay. I'm going to close this VM window, and hopefully this will work. If not, I do have a video for a backup. Ah, it did it. Okay. So We're going to go back in, we're going to play that video. Unhide that slide. Always have a backup, people. Always have a backup. So, yes. So, what we have here is we have an analytical environment. We are simulating an IoT system, okay? So we have IoT power meters feeding data into our database. We are running in SQL managed instance here. The environment that we have set up is a managed instance with a synchronous secondary in one Azure region, and then we have an asynchronous secondary in another Azure region, okay? So we have really 3 copies of this data, okay? So what we're going to be doing is we're going to be feeding this power meter data, this simulated power meter, into the primary. And you can see here when I'm running this query, we can see that this is our primary, and it is in read-write mode. So this is the one that's going to be taking all of the workloads from our environment. We also have this other Management Studio instance where we have the, I'm connected to both of the secondaries. You can see this is the in-region secondary, which is in read-only mode. And then we also have the other secondary, which I'll run that query in a minute. Sorry, I hate narrating over videos. But the other one, you'll see, with this one, we're connecting to it using the exact same connection information. All we had to do was add application intent equals read-only on the connection string, and we know how to route that to the read-only secondary for you. So if you want to do this, there's no changes to your application, or to Power BI, or however you want to connect to it, we just need that application intent equals read-only. Now this one is the secondary that's in the other region, so you can see that the server name is actually different, but we are in read-only mode on this one as well. So again, we have 3 copies of the data. We have the one server that we're going to write to. We have the in-region synchronous server that we're going to read from. And then we have the out-of-region asynchronous secondary that we're going to read from. Now you see on the left-hand side here, I have a meter measurement table. I also have a meter measurement history table. This is a system-managed pair. It's a temporal relationship between these two. When we're writing into the meter measurement table. We're writing into that main table. As we overwrite data in that table, SQL Server is automatically taking care of moving the history records into this other table. Now, the neat thing about this, those 2 tables, different storage types. The meter measurement table is an in-memory table, optimized for allowing us to write to it very quickly. The history table is a cluster column store index, optimized for analytical workloads. So we have the best of both worlds in one interface that we just write to it. SQL Server manages the history. We don't have to think about all the triggers we used to have to write to deal with history tables, all that stuff. This is all temporally managed, and through extensions to the T-SQL language, we can run queries against this and go for a certain point in time over this data. And again, different storage mechanisms between the two. That allows us to optimize for what we're doing at that time. So we're optimized for writes on the main table, we're optimized for reads on the history table. Now what's happening now is we're going to start up this simulator, and I'm going to start pushing meter measurements into that primary table. And as they go in there, again, we are writing to the primary here, because that's the one server in our case that is in read-write mode. If I go into Power BI, you can see that we start with this blank canvas. I'm in direct query mode in Power BI here. So starting with this blank canvas, what's going to happen here is as we refresh, when we refresh this report and as we click around in this report, all these queries are going to be run in real time as we click against the back-end database. So we're going to see the data changing as this comes through. Again, the simulator is running, so we can see the report is refreshing. We've got meter data. As I click around in the zip code list, you'll see the time scale on the graphs change. Again, because it's being done in real time against those back-end databases. But here's the thing. This isn't running against our primary. This is not running against our synchronous secondary in region. This is running against the asynchronous secondary out of region. So there is going to be a lag on your data. No way we can get around that. So if I go to this other tab here, I have the two servers listed here. You see the primary server in read-write mode and the count of records that it has in it. You see the secondary server, the out-of-region secondary server, in read-only mode, and you can see that it has fewer records in the history table. The lag will change over time depending on network latency and how backed up the server is on replaying this information into it. But if you have a reporting workload that can handle a little bit of lag and not having everything immediately up to date, this is a great way to not only leverage. Why do you do out of region secondaries? Disaster recovery. Okay? Normally, your disaster recovery machine is just sitting there doing nothing other than waiting for a disaster to happen. In this case, we have it up and running and can use the power of that machine. Now I want to show you a little bit of the multi-model capabilities here. You can see that I have some additional tables here. I'm creating a meters table. In this meters table, that last column has JSON in it. It's an nvarchar column, just has JSON blobs in it. Well, what if we want to work with that data in addition, in a more relational way? Well, the T-SQL language has extensions that allow us to pull values out of that JSON. So in this next query, you can see I'm selecting the meter ID, the meter description, then I'm doing a JSON value on that column and looking for very specific values within that JSON blob. So in this case, it's going to pull out the install date and the installed by. So when we run this query, again, you didn't have to install anything special to get this. We now get those elements out of the JSON into a tabular result set. All of our tooling knows how to work with tabular result sets. We can go into Power BI and just feed this right into it. Great. Another multi-model feature that's built into the engine is the ability to do key value pairs. I don't know what I'm going to have. So in this case, for each meter there, you can see that we have 3 different values, and they're different value IDs. Well, how do we figure out what those are? I've got a list of those. We foreign key join over to that. Now we can see that we've got the 3 different readings. Scenario here is if you want to speed up your reporting and you have certain point in times that you want to always look for, you could have a background process that does the work of gathering this data and putting it into a key value pair table. Anyone that's ever used HBase is comfortable with this type of thing. And then you can easily, quickly read that without having to do all these calculations. But how do I use that in a tabular way? Well, our friend the pivot operator comes in. So what I'm going to do here is with the pivot keyword, I'm going to take that list, I'm going to pivot it on meter ID, and now you can see each of those values shows up as an independent column. So what we've done here is the first round we took JSON, turned it into columns in a tabular data set. In the second round we took key value and made it a tabular data set. Let's put them all together. We take those 2 queries, join them together on the meter ID, and it gives us one tabular data set combining 3 different models of data. We've got relational, we've got JSON, we've got key value. Now I can take this query, and in the Power BI report that I have another tab that is the same as that first visual that we saw, but now at the bottom you see there's an additional graph or additional table. That is the results of that query we just wrote, and as I click around, it's going to cross-filter that. This also is running in direct query mode. There's nothing additional happening here. This is all built into the T-SQL language. This is all built in when you install SQL Server or use Azure SQL Database or a SQL Managed Instance. this functionality, it's all here for you. One more fun multi-model thing, graph. We support graph inside of SQL Server. So I have this table called installers. When we query the installers table, what we're going to see is we're going to see some data, but we're also going to see this really, really weird looking column at the beginning. And that weird looking column contains the information that SQL Server needs to deal with the graph queries. Now, remember, graphs are edges and nodes. So if you look at this second query, I have 3 tables in my from clause. I have 2 nouns and a verb. So I have installers, I have meters, and I have installed. So what I'm looking for as the results here are, give me what installer installed what meter. So that's the query that we're running here. So we have graph represented data stored in our table, and we are returning it in a tabular manner. And we also have this second query that I'll show you here, or that we have here. Again, 2 verbs and a noun. We have meters that are located in postal codes. Traversing that graph, node, edge, node, allows us to get at all of that information and return it in a tabular way that we could then take this also and join it into that other query. We can put it into Power BI. We can do whatever we want with it because it's a standard tabular data set. All right, with that, that is my demo. Thank you for bearing with the demo failure. Are there any questions on HTAP or Translytics before we move on? All right, before I turn it over to Ajay, I forgot this, and I am mortified. I apologize to those of you online. I know there were a lot of people online at the beginning. I want to thank you for being here, as well as the people in the room. They reminded me about that right before I started, and I forgot. So my apologies on that. But I will turn it over to you for data virtualization, sir.
Thank you, Chuck. So let's move on with the analytic scenarios and talk about data virtualization and what it is. So our journey actually started 3 releases ago in SQL Server 2016. How many of you have heard of Polybase, right? So that's where it started. And we introduced the Hadoop connector, as well as querying data stored in Azure Blob Storage, as well as other generic ODBC sources. And as the industry moved along and we talked to a lot of customers who are storing data outside their traditional relational database, it was important for your traditional SQL customers to be able to query this data and operate on it to do the analytics. So in 2017, we introduced open row set enhancements, which allowed you to explore the data situated outside of your SQL Server database, as well as support for CSV files and database scope credentials. In 2019, we expanded connecting to other relational databases through an ODBC connector, some of which are listed here, like Oracle, Teradata, et cetera, and in fact, even NoSQL databases like Cosmos DB and MongoDB. And in 2022, which we will spend the next few minutes on, is we have completely rebooted this framework. It's the next version of Polybase and gives you a lot more flexibility in connecting to multiple data sources that we will see. So in 2022, we introduced a new connector framework, which is REST-based. And with any HTTPS endpoint, you can connect to any data store, which is object storage, like S3, which is an open source storage format. And you can query that data set, whether it's in your data center or in any S3 supported providers like MinIO or AWS or any other many supported vendors, which we'll talk about. And we also now support exporting and reading from Parquet and Delta files, as well as a much requested feature for SQL customers is CTAS support, where you can create external table as select, which we all had for many years in Synapse or Azure Data Warehouse in the past. So this diagram brings it all together, where you see that from SQL Server or Azure SQL, you can, on the left side, what you see is the Polybase services which existed in older releases. And on the right side is where we invested a lot in both Azure SQL and SQL 22 is building a new framework based on the HTTPS REST API, which allows you to connect to data stored, whether it's in Azure storage through Azure Data Lake Gen 2, Azure Blob Storage, or any S3 compliant storage, and many of the vendors are listed here, such as MinIO, Dell, AWS is also there, part of this. This allows you to not only query, but also export your data to Parquet and Delta, which are standard formats for data stored in a lake. And we will look at a few demos on our scenarios where this virtualization will help you. And scenario number one is, like Chuck showed you, a lot of in-database analytics. And through simple T-SQL, which many SQL customers are used to, you can operate on this data just like your SQL tables and do all your analytics right there. The second thing is it allows you to connect to your data source, all the different options that we showed in the previous slide from a single place, and makes it very easy for you. And the last part with CTAS, especially, you can transform and export your data to necessary formats and then have that one lake system. So let's dive into a demo and walk you through how this works. One sec. OK, so before we get into the actual queries, if you are using SQL Server, you will have to turn on two server-level settings. The first one is the allow polybase export, which is needed for CTAS to export your data. The other one is the polybase enabled option, which will allow you to run those queries, right? So in this example, I'm going to use a movie data set, which you will see is stored as in a local storage as Parquet. And then we will be using that to query and operate on the data and look at the three scenarios we discussed. And you'll also see that there's millions of rows in this Parquet files, and the performance is acceptable for analytical workloads. It also allows you to, for external tables, it integrates very well with our intelligent QP. So you can create statistics and indexes on those data, which will give you additional advantage in terms of query performance through all the query processor goodness, right? So I've created this data virtualization database. And now let's go and create a master key, which will be used for your database scope credential to access your storage outside of SQL. And let me go ahead and next create a S3 movie database scope credential. And I'm specifying my identity as S3 access key, since my data is stored in the S3 storage. And for the secret, I'm specifying my credentials to connect to the S3 storage, which I've set up. So once I create the database scope credential, you can see in the results that the key is available there. Next step is to create the external data source to point to the URL where my data source is. And you can see it uses for location the S3 prefix, the IP address and port, as well as the folder or the bucket where the database is, right? Now, let's see how to query or explore the data. So we have, as I mentioned, we have extended the open row set query format, where you can specify the folder where your data file is, and you can specify the format as Parquet, and the location of the data source, which we created above. And you can see that it returns the movie names and the genres for each of those movies, right? These are all sitting in files in Parquet, but this allows you to do a relational exploration of your queries. The next thing is, how do you get this data into this, right? You can use your traditional select into. So I'm going to query the ratings table here, which has 25 million rows. And I'm going to do some T-SQL converts, joins. All the things are supported completely with Parquet files. So the same thing, we extended the open row set, and you can do the convert. And once this will take about 10 to 15 seconds to run. And you will see that the data gets imported into your database. And then you can do your traditional joins or any other operations with this data with other tables in your system. So there, the data is already imported now. Next. So these are all good to have. And you can next create an index on this and operate on this. But With data virtualization, our real goal is not to have to move the data, right? The real benefit is how do you work with the data set and let it reside where it is. And you don't want to create multiple copies of the data, especially if it's changing continuously and new files get created. You don't want to set up jobs to completely import it every time and have to work on it, as well as it not only creates multiple copies, but it also bloats your database. So this is where you will see how we do the external table. And external table now supports the Parquet format. As you can see, create external table, we specify the Parquet file format. And then once I create that, I can go ahead and create the actual table itself. Once I create the format, I specify what the schema is. I specify what the location of the Parquet file is. And this does not bring the actual data. This is all we are telling SQL Server is, here's your table structure when you read the Parquet file. So when we query the Parquet file, we can translate the data in the Parquet files to the schema. So this is all just metadata sitting in SQL Server. And now, once I can also create statistics on top of this external table, which will allow me to do more intelligent queries, right? So I've done that. Now next, you can see that we can create views on top of this, where the views can be a mix of data stored in your relational database, as well as data sitting in the Parquet. So this is pretty cool, actually, where you can do your OLTP queries and the data set sitting in your database along with that. Now I'm doing a select from the view, which joins the data in your relational database with the Parquet and returns a result set that you see here. Let's say I want to do like a top 100 movie ratings by rating disorder. So we can actually leverage the query processing to go and do your sorting and get the right data set you want. So that's what you see there. So now you saw that we created an external table, we created a view, we joined with a local table with the Parquet file and exported the results. What if I wanted to export this view to a different storage? We got it from Azure Blob Storage. Sorry, we got it from S3 and relational database, and you want to go to a ADLS2 or to Azure Blob Storage, you can do that too. So I'm going to go ahead and create a database credential to my Azure Blob Storage. Note that I specified shared access signature as to my storage account. So I have permissions to access the storage. Next, I create my data source and specify a new prefix. We support ABS prefix, just like the S3 prefix, and which points to the blob store on the folder where I want to export it to, which is what you see here. And then I can just run. We have some system table queries you can run like DMVs. So here sys.external data sources shows me all the external things we have done. So we have one for S3 and one for the ABS we just created. Now we can then create a new external table to that Azure Blob Storage and export this data from that view, which is sitting in relational table, plus your Parquet in S3 to your Azure Blob Store, right? So the way you read this query is from bottom up. So I want to take the results of the view, put it in the Azure Blob Store in that location, and here's my external table, which uses CTAS query as select from that view, right? So once you run this, you will see that the entire table is exported to your Azure Blob Storage account. Right, I'm going and creating the external table. This takes a few seconds to run. And once that's done, the top 100, I can just query my view, external table. It'll return my top 100. This is actually querying your Azure Blob Storage to return the result set. Any questions on this? Anyone online? No questions? Yeah, there's a question here.
Is this available in Azure SQL DB as well, this functionality?
No, it is not.
It's not.
Yet. It will be coming there.
Okay.
Yeah. So yeah, here's the blob storage which we had created from T-SQL. If you go to Azure Storage Explorer, you can see your Parquet file that we created through CTAS is available. Yeah, it's available for SQL Server managed instance too, I think. But it's just the cycle of rolling the updates and making it available. So it'll be there in all flavors. So that's all I have to share for data virtualization. Please do try it and give us feedback if you have any questions. I will hand it back to Chuck to talk about the third bucket.
All right. Thank you, Ajay. And now we are going to be talking about Synapse Link for SQL. All right. How many of you have tried this feature out? Couple? I'll be interested. Come find me afterward. I will be interested to take some of your feedback on this. With Synapse Link for SQL, what we've tried to do is we're trying to break down that barrier between transactional and analytics. I've heard some people refer to this as an HTAP thing. It's not. This is actually anti-HTAP, isn't it? Because remember, HTAP and Translytical, you don't want to duplicate your data unnecessarily. I still consider a readable secondary an HTAP or Translytical solution because you aren't doing it specifically for the analytics. You're doing it for another reason. You're doing it for HA or DR. In this case, we're actually taking a copy of your data and moving it into Azure Synapse Analytics. So what does this do for us? This is the E and the L of the ETL or ELT pattern. We want to take the pain out of that data movement and out of the ETL process. We also are doing this in near real time. One of the things that, if you want to do this type of thing and you're doing watermark queries or something or running over CDC tables, that's batch-based, there's latency there, and you're adding load to your system. Because if you're storing the data in CDC tables, that's the step to store the data in CDC, then the step to query the data in CDC. If you're using a watermark, you're actually running queries against your database, adding load to your transactional system to get that data out. Now, granted, you could offload that load to a secondary, but you're still running queries against your database. Synapse Link does it a little bit differently. We're watching the transaction log. We're scraping the transaction log for you, and we are pushing the data to Synapse. It's not a pull. Synapse Link is a push. All right? So how does this work? Well, you start off, and I'm going to talk about it in SQL 2022, and when I get to all the animations done, I'll tell you which pieces aren't necessary for SQL DB, because this works in both 2022 and SQL DB. So you've got your on-premises SQL Server sitting there, doing its thing like it always is. In Azure, you have your Azure Synapse Analytics workspace. You have your dedicated SQL pool. This, yes, it is a dedicated SQL pool. It is not a serverless data lake. It is going into a dedicated SQL pool. That you create in your environment. You also create an ADLS Gen 2 storage account. We use this as a landing zone. Anyone familiar with IoT scenarios know you always want a buffered ingestion point. You don't want your IoT devices writing directly into your data store. Same concept here. We don't want bottlenecks on either end holding up the other end. So SQL is going to use this landing zone. We put the data there, Synapse picks the data up and brings it into its environment. Self-hosted integration runtime. This should feel very, very familiar to anyone who has used Azure Data Factory or Synapse pipelines. It is the same component with a little bit of a difference in the way we use it. If you're using it for ADF pipelines or for Synapse pipelines, the integration runtime does the work for you. So if you are saying, I want to copy from an on-prem SQL server up into blob storage, the runtime is going to do that work for you. All right? Thank you, 15. In our case, this is a communications channel. This is command and control. It is not moving the data. SQL Server moves the data. This just tells SQL Server what to do. okay? So you don't have to have all the extra data movement handled, like if you had to open up ports to get to your blob storage or something, that you don't have to do that from the integration runtime machine. All right, then we have this little thing in the Synapse world called the ingestion service. This is where the magic happens on getting the data out of the landing zone into your dedicated pool. All right, so we can walk through the animation, the rest of it. So we've got Synapse calling out to the self-hosted integration runtime, telling SQL Server, I want to replicate this data. SQL Server pushes that data to the landing zone. The ingestion service picks that data out of the landing zone and puts it into your dedicated SQL pool. The way this works is at the first time you initiate this, we take a snapshot of the tables that you tell us to take a snapshot of. The whole table gets put out into that landing zone and pulled in. Once we have that snapshot, it becomes a trickle feed. As you commit transactions on the back end, we roll them into your dedicated pool. Remember, this is a push from SQL Server into the landing zone. It's not a pull. This is built into the engine. We built a new thing called the SQL Publisher, which is powered by a change feed technology that we have in the engine. Built by the same team that does our CDC and replication work, but it is not CDC or replication. It's a brand new thing designed to, one of our core tenets was minimal impact on the source system. We want to do this with as little impact on your transactional system as possible, which is why we have SQL pushing the data. Now, how does this differ when we look at Azure SQL DB? Number one, no self-hosted integration runtime. Because it's in Azure, we can talk between the two services. Number two, the landing zone, we manage it. It's part of your Synapse environment. You don't have to manage it. Common question I get there, I'll head this one off at the pass before I get it. How about if we need that landing zone encrypted? By default, all Azure storage accounts are encrypted, right? What if I want to encrypt it with my own key? The key that, if you do customer managed keys, the key used to encrypt the landing zone is the same key used to encrypt your Synapse environment. Because the landing zone is part of the Synapse environment. You will never see that landing zone in Azure SQL DB. You don't have access to it. You do have access to it in the SQL Server world because you created it. Here's the thing, though. We do not support using what's put in that landing zone for anything other than Synapse Link. We manage the cleanup. We manage the file formats. We can change that at any time if we need to. We do not want anyone taking a dependency on that because we can change it and will change it if we need to. Just because you can see it, just because it's there, doesn't mean you should pick it up. I had to tell that to my kids when they were little. Just because it's there doesn't mean it's a toy. All right. So I think I can go into a demo now, and I am going to try again on this one because this, even if I have that same problem with this demo, I can make it work.
Can I ask a question? Also, two questions.
Questions?
Yeah, you said it's a push from on-premises from SQL Server. So I'm assuming no contingency on the transaction log if the link is broken. Like my logs will not get truncated.
So the question is about log truncation, and yes, since we are dealing with logs in the transaction log, or records in the transaction log, if it cannot write out to storage, you are right, those logs still stay active in your transaction log. That is a problem. And we do have retry lives, so if it's a transient error, it's not going to be a problem. We'll pick it up. But yeah, if that storage account is down, or your network link to it is down for an extended period of time, you could run into logfall issues.
All the restrictions we have today on the Learn website, is some of those in your backlog, or is it going to get reduced? Probably like in next few quarters? I know it's a very generic questions, but that's what I get asked when I go back from this conference.
The question is about some of the restrictions that we have. We do have some restrictions on this. They are all documented on in our public documentation for the feature. Yes, they are on my backlog. We are going through semester planning right now. Actually, I have been reviewing documents all week from the people back in Redmond, updating things and trying to see what we can fund for the next semesters.
Because I asked you this at PASS. I went back, they asked me, and they're going to ask me again when I go back on Monday. So.
A couple of the big things that we do get questions about, some of the limits, I'll head this off before we get more questions about it. We don't support DDL actions on tables are being replicated. That is one of the biggest complaints that we get, and it is the top on my, or is one of the tops on my backlog. Another thing is to set up and configure this, you require control DB permissions. That is another huge thing on my backlog, is to reduce the permission set required to set up and configure this.
Thank you.
Anything else before I go into the demo real quick? And this will be real quick because I know we are at 7 minutes before the end. All right, so what I have here is, in good cooking show form, I have an Azure Synapse Analytics environment set up. And what's in this Synapse environment is I have a dedicated SQL pool. I have 2 link connections running, one for the cloud and one for on-prem. Now, when you set up a link connection, you get to choose what tables you want to replicate from the source. You get one of the other restrictions that is not going away anytime soon is these tables require a primary key, because we do need to do a comparison. We need a key to compare on. You specify the target that you want. In this case, since my 2 source databases, one in the cloud, one on-prem, are identical schemas, when I write them into Synapse, I'm writing them into 2 different schema names with the same table name and same structures. And then what I do is I union them together in a view for my reporting. So I've got data coming from 2 different sources at the same time into the same dedicated pool. One from the cloud, one from on-prem. You get to choose your distribution type. If you're familiar with Synapse, you can do round robin, you can do hash distributed, or you can do replicated. That's all Synapse side stuff. And you also get to choose your Synapse structure type. Do you want it to be a heap? Do you want it to be a clustered column store index? In this case, these are already up and running. We are replicating data in, you also get to choose two other very important things here. Number 1, how many cores do you want to process this data in that ingestion service? The more data you're pushing through, the more cores you're going to need in the ingestion service, because that's what's reading out of the blob storage and writing into Synapse. We are actively working on a performance paper giving you guidance on, we're using a TPC-H workload with different amount of transactional throughput on that to give you guidance. Expect that in the next couple of months. So if if you want to see something like that, we are working on it. The other thing here is, do you want continuous mode or do you want batch mode, or scheduled mode is what it's called. Continuous mode is near real time. As the records are put in the landing zone, they're picked up and moved into the dedicated pool. Schedule mode is, if there's data sitting there, we'll process it, then the ingestion service goes to sleep for a while. Between 20 and 60 minutes, you choose that interval. Then it wakes up, looks for data, processes that data, goes back to sleep. Cost savings, if you can are okay with some latency. Yes, we're adding latency back in like you have with the batch system, but you still didn't have to write any code to make this E&L work, okay? So if I run a query against my dedicated pool here, this is going against my customer's view, which is unioning those two data sources together, the source from on-prem and the source from the cloud. You can see we have 261 records coming from the cloud, 402 coming from on-prem. 5 minutes left. I can do this. Thank you, 5. What I'm going to do now, and this is where the font size on the VM doesn't really matter, I am going to go into my 2 different sources. I'm going to add 100 records to the cloud source, and then I'm going to add 50 records to my on-prem source. All right, so what's happening now? what's happening is that the two engines, the two SQL engines, those transactions are committed to my transaction log. The SQL publisher, through the change feed, is taking those, grabbing them, pushing them into blob storage, or ADLS Gen 2. It's an ADLS Gen 2 storage account. It's grabbing them and it's pushing them there. Once they are securely in that storage account, we can go through and mark those transaction records as clean. You can get rid of them. Then the ingestion service is picking that up and moving it into, and remember, there's two different sources. I have two different ingestion services running here. I have one for the cloud, one for on-prem. It's picking that up and moving into my dedicated pool. So if I go into that query again, I'm going to rerun this query, and we should see 361 from the cloud, 452 from on-prem. So just in the time that I was explaining that, this data was replicated. We do not call it real time. We call it near real time, because it is not real time. There's multiple hops in here. There will be some latency, but it's not going to be hours of latency that you see when you're doing batch processing. Now, okay, if you are doing, thousands of transactions per second and are trying to do it with 2 cores on the ingestion service, yes, you will see a lot of latency, because it's just, you have to size the ingestion service to the volume that you're pushing through it. All right, with that, I'm going to switch back into the presentation, and we'll go right to the closing slides. You know what? We forgot to put the eval slide in. We're in trouble. Simon was standing out there. He was going to yell at me. All right, in closing, virtualization, HTAP and Translytics, Synapse Link. This is what my team works on. This is what my team does. We are committed to making these types of workloads work well in SQL Server and Azure SQL DB. And any feedback you have for me, I will be here the rest of today and or half day tomorrow before I have to try and get a train back to London. I don't know. But with that, we've got a couple minutes for any last questions. Someone's not shy. Let's go.
Thank you for the presentation. You said dedicated. That means it doesn't work on serverless?
Correct. It does not work on serverless pools. That was a limitation. There's, if you want to talk about it, there's actually a technical reason behind why we had to do it this way. I actually got accused of that we were just trying to pad numbers on this. No, there is a technical reason why we had to go with dedicated pools. Question in the back.
Repeat the question.
Yeah, the question was, is it under the roadmap for serverless pools? We are looking at it. We are trying to see what we can do there. It's definitely something that we've heard from a lot of people. But like I said, there is a technical limitation because it has to do with Parquet files, because Parquet files are immutable. How do you do high update, high delete workloads with Parquet? It really becomes complicated. Yes?
I had one as well. For the continuous versus batch option that you showed us a few moments ago, is there going to be any performance hit on analytic queries hitting that dedicated pool while the batch is ongoing if you choose batch mode? Any impact there?
So in general, whenever we're writing data in, we are consuming concurrency slots on the dedicated pool. So even when we're in continuous mode, we are still consuming concurrency slots. So when we're running those batches, and this is going to be part of, I'm making sure that this is part of that performance paper, is how many slots are we using, so you can think about sizing your DW as well. But yes, we do consume concurrency slots when we are doing these operations. Anything else? My gosh, we are just about on time.
Yeah.
Thank you so much. Enjoy the rest of the day. Enjoy tomorrow. Thank you all for being here. Thank you all for being online.
Yeah.
We'll be in the booth on and off if you want to stop by.
Thank you, folks.